Okay, yeah, that's fine. Yes, cool. Okay, cool. Let's get started then. So here's the warm-up. Just 2 questions, pretty simple. And I'll give you guys a few minutes to work on this. Oh, by the way, do you guys know what an action figure is? It's like those miniature figures, like um small people basically. Oh, cool. Same here. I think I got one for my 10th birthday. It was pretty cool. You can't hear me? Okay. You guys can hear me, right? Hello? Yes.
Yeah, I can hear you.
Okay.
I can hear you.
Okay. Let me try and talk to Ian then. Am I soft or can you hear me loud and clear? Loud, cool. Okay. Well, let me see, what can I do? Oh, by the way, for the first question, I would like you guys to simplify. So if you guys can find a greatest common factor, like we did in last class, we can then divide those numbers by the greatest common factor and get a simple ratio. Cool? Yes, yes. Yeah, Bowen, you're right. There's someone else who did not simplify. Okay, are you guys done? Cool. So let's do the first question. Press enter in 3, 2, 1, go. Okay. Yeah, seems like you guys are already texting me the answers, so I think I'll just go over it as a class. Yeah, yeah. Seems you guys got that. So again, we have 30. Oh, why did I have pink this time? Okay, well, that's cool. 8. And that, we can simplify this by 2 because both of these are divisible by 2. And we can divide both sides by 2. And then we get 15 to 4. And then what about the second question? Press enter in 3, 2, 1, go. Yep. It's also very simple. Since a scale of 1 to 144 is basically saying that if the model was 1 inch tall, then it will be 144 inches tall in the real life model. So if it was 10 inches tall, then in the real life model, I'll just take it and times it by 144, and I will get 1,440. Cool. Okay. These are pretty simple. So I think most of you guys got that. So let's move on. Cool. So today we'll be learning about how to do operations with decimals. Does anyone know how to do like, well, first of all, you guys know decimal and what decimals are, right? Yes, cool, okay. But I think like last class, you guys had some difficulty trying to divide with decimals. So today we'll be going over how to add, subtract, multiply, and divide decimals. Cool? Okay, so let's get started with adding and subtracting decimals. And actually, for adding and subtracting, it's very simple. Like first of all, what you have to do is basically think about the decimal points as like specific placeholders where you can add and divide, or sorry, add and subtract. So for example, a digit on the 10th can only be added by another digit on the 10th. So say I have 10.5 added by 10.3. Yes, Ian, yes. Something like that, yeah. So you see this and you see how I ordered the decimals in the same place. This makes it very easy because the digits are in the same place as well. So now I just add down and I get 158. So then the same rule applies for like bigger numbers like this. 2, 7, and 1. See how I ordered the decimals here? I can easily add it together and get 1.74. Cool. So this should be a review for most of you and shouldn't be too hard. So here we go. Let's do some practice. And I give you a picture on the right to show basically, oh, that was bad. Right here, and it shows basically, oh, that's still bad. Right here, there you go. And it shows that you can put the decimal places in the same place, and afterwards you can just drop down anything that's not in the decimal places, and then you can add the digits together like that. Okay, I think most of you guys are done. So let's do the first question then. So we have 49.2, and we add that with 1.394. You see how I order basically the decimal places straight down, and this allows me to basically make sure that I add the digits correctly. Else I may add like the 2 with the 4 or the 9 with the other 9, so it will mess up my addition. So this is a kind of a way that you can make sure that you have the right addition down. So now just pull these down because they're not being added by anything, and then 2 plus 3 is 5. And a point here, we have 0 and then 5. So the first answer is 50.594, or 50 and 594. Yeah, and also you guys can also put zeros at the end if it helps you, and that'll work as well. Okay, so that was the first question. Let's do the second question now. So we have 485.75, and we add that with 0.5. And this question actually tricks some of you. So make sure that you line up these decimals correct, because some of you added the 5 with the 5 thinking that, oh, this is 485.8, but no, you see, added with 0.5, not 0.05. So you can see that I ordered it, and then this allows me to get the correct answer of 486.25. Cool? Okay. And then here, let's load in answers for question 3, and then press enter in 3, 2, 1, go. Oh, I think I was a little fast. Okay. You guys can load the answer for question 3 and then press enter in 3, 2, 1, go. Hello? Okay. Okay. Oh, you didn't have time to do them. Okay, I'll give you guys some more time. Okay. Just it shouldn't be too bad. Just make sure that your decimal points line up when you're adding the addition together, basically. That's it. It shouldn't be too hard.
这个盘子不能转。
Are you guys done? Shouldn't take more than if. Okay, okay. You know what? Let's do question 3 since you guys have some trouble with question 3. It's not that bad. So we have 49.5783, and we add that with 0.475. So again, I ordered the decimal points in the same place. Make sure that I add the numbers correctly. So now any number without the number beneath it or above it gets pulled down. So this is 3. This is another 3. This is 1. This is 5. This is 1. This is 0. This is 1. And then we get this 50.0533. Cool. Does that make sense? Is this easy?
Yeah.
Yeah. Okay. And then, yep, some of you guys already did the last few. So again, for 53, 6.462. All we do is that we add it with 6.4. Make sure decimal places line up. 2, 6, 8, 9, and 5. Easy but no time. It shouldn't take you so long though, since all you're doing is you're ordering it, and you're just bringing the ones without numbers down, and then with this, this, and this. Okay. Oh, I guess you were stuck on number 2. Okay. Here, is everyone done with question 5? Yes or no?
I know what the answer is to question 5.
Okay. You want to explain it?
Yeah.
Okay. So tell me what you did.
So I put 485.6 at the top.
Okay.
And then I added 0.4 and I put a point right below the other point.
Yes.
I added 6 and 4 together, which makes 10. So I put 0 there and then a 1 at the top.
Yep.
And then I put a decimal right before the 0.
Yep.
And I added 5 to 0, which was 5.
Wait.
And
Wait. Think about this. You see this?
yeah, and then I added 1 more to 5, so it's 6.
Yes.
And I just put 8 and 4 there.
Yep. See, it's not that bad. It's really fast. Once you guys get the hang of it, it's super easy. Okay. Yes. It's just 486. We don't need a 0. Cool. Yeah, let's do one more practice problem since some of you guys haven't got that completely. So let's do a quick one. I'll give you guys a minute to do this one. Let's see. Okay. Give you guys a minute. Oh, some people are fast, yeah. Yep, okay, yeah, okay. Oh, you guys are fast. Seems like you guys got this time. So again, 7 plus 3, 0. We have 1. This is another 0, so this is 1 here, point here, add this up, we have a 9, 2. You take the 0 out, so it's just 29.1. Cool. Seems you guys got this now. You got a hang of this. Nice. So let's move on to the next thing. And let's do multiplication. So now we're going to start counting the places after the decimal points. So instead of adding with decimal points, we're going to count the number of places or the number of digits after the decimal points. So you guys can see on the diagram on the right that this is how you multiply decimals. You count the amount of numbers outside, or sorry, behind the decimal point. So in this case, this number has 2, this number has 1, and then 2 plus 1 is 3. So once I finish time multiplying the 36 with the 173 and adding them together, I get basically 6,228. But then I put the decimal point 1, 2, 3. 3 spaces because I counted that there's 3 digits behind the decimal point, and now there's 3 digits. It should be 3 digits in the answer as well. And that's how you multiply decimals. It's very simple. Cool. Okay. Does anyone have any questions? No? Anyone else? Should make sense. No? No, okay, cool, okay. Yeah, it's very simple. It's just a single rule. It's not so different from normal multiplication. So like, even if I do like 12 times 36, 2, 1, 7, 6, 3. We have 2, 3, 1, 4. And then say I put 2 decimal points here. The same thing. I get 4.32. So it's very, very simple. All you have to do is count the number of digits that are in the two numbers that are being multiplied. And then you can use those digits to determine where the decimal place goes in the result. Okay, let's do some practice then. Okay, here's some practice and I'll give you guys 5 minutes to finish them. Cool? Shouldn't take you that long though. So time's up. Seems most of you guys got the answer correct. So let me go and start with the first question. How about here? Does anyone want to explain how they did the first question? Sure. Yeah, go ahead.
So what I did is just like I just took out the decimal place and just know that there's one number after the decimal place, so I just write a one on the side so I know how many decimal points I need to place, and then just do 43 times 44. This is 1,892, and then I just add in the one, and go from the back and go add in a one decimal spot, which put in front of the 2, so it just gets a 189.2.
Yeah, cool. Does everyone understand that?
Yeah.
Yeah, cool. Okay. That was a pretty good explanation, Bowen. Nice work. Now let's see the second one. So same principle on the second one. 5.7 times 5.2. We have 2 decimal places from the 7 and the 5. Now let's do the multiplication normally. So we have 35, 25, so 28. Now we have 2, 4, 1, 5 times 2 is 10, 11. We have 5, 2, 1, 4, 1. So we get 14.25 for this question 2. Cool. Okay. And then question 3, most guys got the same thing. Yep. It's very simple actually. Question 3, all you do is you do the same thing. Count as 2. And then we have 2 decimal places on here. 0, 2, 8, 1, 16, 17.8. And then you don't need to care about the 0 at the end. Okay, how about this? Let's load the answers for question 4 into chat, and you guys can press enter in 3, 2, 1, go.
Question 4.
Yes, question 4, yes. Okay. Anyone else? I see Bowen answered. Some of you guys answer on top, but I want to see everyone answering. Cool. I want everyone's opinion. Okay. Anyone else? No one? Okay. Seems like I got the right answer. So again, let's do this as a group. We're multiplying this by 1.2. So now 2 times 7 is 14. Add the 1. 2 times 4 is 9. Now 2 times 3 is 6. Afterwards, we do the same thing. So then 1 times 7, 7. 1 times 4, 4, 3. Then Andrew, how many digits are there in the decimal place this time?
Four.
Yes, 4. So once we finish this, we go 1, 2, 3, 4. So you guys get 0.4164, which most of you guys answered correctly. So that was it. Cool. So I assume everyone's good on the last question as well. Does anyone want me to explain it? Or are we good? Okay, seems like we're good. Now let's go to the tricky part, which is now division. Oh, well, there you go. So, but what about division? I ask. So let's start with some easy ways to simplify dividing decimals. So when you see like a really big number, like let's say 0.375 divided by 0.8, that seems very hard, right? Yeah, division's hard. This seems super hard, right? No, not really. Okay. Okay. So Donald, do you want to explain? No? Okay. Yeah, it's not hard, but yeah, okay, sure. So my method of making these divisions easier is I times them by 100 on both sides. So I basically make them into whole numbers again. Wait, no, 1,000. I think it's 1,000. Yeah. Yep, it's 1,000. Then I times it by 1,000 and it makes them into whole numbers and allows me to divide them much easier than having to do fractions or decimals. So you guys remember how we did with the remainders in division? I remember some of you guys had problems with that last time. So let's review that today. So again, with remainders, we first create a division table like this. You don't really need to find the greatest common factor, Ian. Actually, using the division table would solve the question much faster since we want to just divide them without finding the greatest common factor because it's unnecessary, actually. Actually, if you want to simplify the fraction, yes, you can. If you want to simplify the fraction, that will work. But in the previous example, it won't work because I don't think there was a greatest common factor between those two numbers. Yeah, you can also change it into fractions, yes. And then you can simplify the fractions and make it easier. Yes, if you can't simplify it, do the division table. If you can, then simplify it first and then do the division table. So like if I had like 25 and 10, I can divide by 5 on both sides and get 5 divided by 2. And that'll make my life a fair bit easier. So let's do the division table of 5 and 2, and let's remind ourselves on how to do remainders. So let's do this. How many times can 4 go into 5? That will be probably 2, so I have 2 here, and then I'll have 4 here. Now 5 minus 4 is 1. Now we have a remainder of 1. Now who remembers what we can do with this remainder? Now, okay, Ian. So how did you get? Well, actually, I want you to turn that into a decimal. What you got into a decimal. Yes. So Ian got 2.5. The way that he got 2.5 was that he added an extra 0 at the end, adding a decimal, and dividing 2 by 10 is 5. And we get 2.5. If we do 5 divided by 2, it's 2.5. Let's do another one. Let's do 7 divided by 3. Who here can explain what I did with my method? Anyone? Okay, you can go, Gamboa.
So how you do it is just you have to like drop the division table thing, and it has to do 2 versus get 6, and then the remainder 1, and you can add some zeros behind because it'll still be 7 equal to 7, and then you can by adding those zeros you can add a 0 onto the back of the 10, I'm pretty sure, and then add a decimal point, and then just do the 10 divided by 3, which is goes into it 3 times to get 9, and then you get 1, and then you add another 0 and get 10 and 3, and then do that. Come on, doing that, and then just get 2.3 like that.
Yep.
Repeating.
So yeah. So what I just saw here, I did the division, I added a decimal point in order to add an extra 0 at the end. And then in the end, we get 2.33 repeating. So this bar basically saying that I have many 3's on the end, because when you divide something by 3 unevenly, you have a repeating basically string. You have a repeating amount of 3's, and it won't stop. It'll go on infinitely. Yep, it'll go on forever. Cool. Does anyone have any questions? No? Okay, let's do some practice then. Oh, sorry. You know what? Let's watch the video first. I think this guy can explain it much better than me. Oh no, it was 7 divided by 3. It was not 3 divided by 7. It was 7. Yeah, no, yeah, it was 7 divided by 3. So it's not 3 over 7. It's 7 over 3. Okay, let's show you a sample. Can you do this?
In the last section, we learned how to convert some special base 10 fractions into decimals, and vice versa. Now we're going to learn how to convert any fraction into a decimal. And it turns out to be really simple. All you have to do is divide. Since a fraction is really just a division problem, if you go ahead and do the division, you'll get an answer. And that answer will be the decimal value of the fraction. Now there's two ways we can do the division, the easy way and the hard way. Now, just because I'm mean, we're going to start with the hard way. Let's take the fraction 1/2 and convert it into a regular division problem with this division symbol. Now all we have to do is follow the procedure for division. We just see how many times this 2 divides into this 1. Uh-oh, it won't divide any times. 2 is bigger than 1. Looks like we're going to need some help. And that's where the decimal point comes in. Now you remember that in the last section, we learned that 1 could be written as 1.0 or 1.00 or 1.000, and its value is still 1. Let's try doing that here and see what happens. After the 1, put a decimal point and then a 0 in the 10ths place. Now our division problem looks like 10 divided by 2, and that's easy to do. The only difference is we have a decimal point. Let's ignore the decimal point for a minute and pretend that our problem really is 10 divided by 2. So 2 will go into 10 5 times, because 5 times 2 equals 10. And that leaves no remainder. So we're done, right? Not so fast. We've got that decimal point to deal with. And we know that 5 can't be the answer because 5 is bigger than 1/2. We just need to include the decimal point in our answer for it to be correct. We put it directly above the decimal point in our problem. There. Now our answer is 0.5, or 0.5, which is the more proper way to write it. So by dividing, we figured out that the decimal value of 1/2 is 0.5. Now let's try converting the fraction 3/4 by dividing. Of course, we start by rewriting our fraction like this, 3 divided by 4. And again, we run into the same problem. 4 is too big to go into 3, so it looks like we're going to need a decimal point here too. Let's put a decimal point after the 3 and a 0 in the 10ths place to make 3.0. Now our problem almost looks like 30 divided by 4. Now, if you remember your multiplication table, you'll know that 4 goes into 30 7 times, because 7 times 4 is 28. 30 minus 28 leaves a remainder of 2, but we don't want a remainder, so let's keep going. 4 is too big to divide into 2, so the only way we can get rid of the remainder is to use another 0 in the 100ths place, which makes the number we're dividing up kind of look like 300. Now we can bring down that extra 0 to make the remainder look like 20. And 4 will go into 20 5 times, because 5 times 4 equals 20, and that leaves no remainder. Oh yeah. But don't forget, we need to include the decimal point in our answer. Now if you've kept your columns lined up like I have, you'll see that the decimal point goes right here, and that makes our answer 0.75. So the decimal value of 3/4 is 0.75. All right, let's convert one more the hard way. Let's find the decimal value of 1/3 by dividing 1 by 3. Again, 3 is too big to divide into 1, so we'll need to use a decimal point and another 0, which makes our problem look like 10 divided by 3. That's easy. 3 goes into 10 3 times, because 3 times 3 equals 9, and that leaves a remainder of 1. Just like before, we don't want a remainder, so let's use another 0 so we can keep on dividing. And that gives us 10 divided by 3 again. Well, we know that 3 goes into 10 3 times and leaves a remainder of 1. Still a remainder of 1. Well, it looks like we're going to need another 0. But that's just going to give us 10 divided by 3 again, which is going to give us another remainder of 1. This looks like it might keep on going forever. Some fractions are like that. If you divide them, you'll see a repeating pattern of numbers that continues on forever. So the decimal value of 1/3 is 0.33333333, and 3's that keep on going forever. But since we can't keep writing 3's forever, we can just stop and round the number off. Or we can use this special symbol that means this number repeats forever. All right, so all we have to do to convert a fraction into a decimal is divide. And so far, we've been doing that the hard way. But now, we're going to do it the easy way. We're going to use a calculator. Let's try a couple with a calculator and see what we get. To convert 1/4, we just punch in 1 divided by 4, and we get 0.25. To convert 2/3, we just punch in 2 divided by 3, and we get 0. A whole lot of 6's. Looks like we have another one of those repeating decimals. Yep, this way's certainly easier and quicker too, but it's important to know how to do it both ways. The 5 fractions that we've just converted are so common that it's a good idea to memorize their decimal values. Here they are again so you can review them. 1/4 equals 0.25. 1/3 equals 0.33333. 1/2 equals 0.5. 2/3 equals 0.66666. And 3/4 equals 0.75. So that's how you convert any fraction into a decimal. You just divide. And we already learned how to go the other way to convert a decimal into a fraction in the last section. So be sure to review it if you need to. In the next section, we're going to learn a few tricks that we can use to help us compare the values of fractions. But before that, a quick review. To convert any fraction to a decimal number, all you have to do is divide the top number by the bottom number. Usually when you divide a fraction, you'll need to do decimal division. By using the decimal point, you can keep writing zeros in the decimal number places and continue dividing.
Okay, so we were just talking about the calculator in the video just to make a point that some people just memorize the fractions and the decimal output so they can easily do the questions. Like say, I would memorize that when you do say like 1/3, it's just 0.3333. Yep. You should do the division yourself for practice. And even if like say you don't have a calculator, then you would have to do the division yourself. So it's really good practice that you guys do it without a calculator, but it's also good if you guys can memorize some of these. So like 5 divided by 2 is just 2.5, because if it's undivisible by 2, then you add just 0.5, which is half. Yeah. No. Well, actually, maybe. Let me see. If we have enough time. So let's finish this video and then you can get back to the lesson.
Until you have no remainder. Sometimes decimal division results in a pattern that keeps repeating forever. When that happens, you can draw a line over the repeating digits instead of writing them forever. Once you know how to do decimal division, I recommend that you convert fractions using a calculator since it's quicker and easier. And as always, be sure to do the exercises. And don't forget to practice dividing the hard way too, because if you're ever stranded on a deserted island without a calculator, you need to be able to do your math homework. To see
Here's some 4 practices, and remember, if there's a 0 at the end, you guys can remove the 0 and just put nothing there. Oh yeah, I forgot to add. For let's say for the 2 to 4, let's round to the nearest 10th. You guys can get some rounding practice in the nearest 10th. Okay, let's go over the first question. Not too bad. So what I do is I times these by 10, times by 10, and I get 45. Oh, okay. Yeah, Laura, just listen to me. I'll explain these very quickly. So if you have like decimals like these, you can just times them by 10 on both sides. It'll make it very easy for you to divide these decimals. And then 45 divided by 5 is just 9. So even though that there's decimals, if you multiply by like 10 or 100 on both sides, you can simplify things a lot. Okay. And then for another example, like we do this, 0.3 divided by 0.1. We times these by 10. We get 3 divided by 1, which is just 3. So it makes things a lot easier. So now let's do the second question. Don't know why I put the second question as the hardest question, but let's do it anyway. So we have 45 divided by 56. And again, I'm just expecting you to round to the 10th. So you guys don't have to do the whole, I think it's almost infinite string of numbers. So 45 divided by 56. So we know that that can go in once. Minus 45, we get 11. Then we add a 0, like the video said. So now we have 110. Let's try 90. Let's see if 90 works. So now we have 20, and yeah, 45 cannot be fit into 20, so we have 1, now we have a 2. Oh, sorry. Yeah, no, that's not right, that's not right. Erase this. I keep forgetting that this goes on the outside, that goes on the inside. So this is 0 0, and then try and fit 56. So I think that's 8. So let's do 56 times 8. And then we get 8, 4, 44. Yep, that fits. And then we get a remainder of 2. So this is an 8, and then I know that 2 does not fit and 20 does not fit. So that'll be 0. So the answer for number 2 is just 0.8. Since we round to the 10th. Cool. Sorry if that kind of confused you guys. Okay. So let's do question number 3. And then, yeah. Times this by 10, times this by 10, yeah. 5, and then you have 900. So we have fit this into 5. So we have 500. And we add another 0, 5,000. So I think that, yes, 45 awards. We can do 45. That leaves us with now another 500. So this is a 5 repeating. Cool. And then after that, we round to the 10. So this is basically, since it's 0, we don't do anything with the number previously, so it's just 0. So question 3 is just 0 because the number is so small that we round to just 0. We round to the 10th place. Okay, Ian, you don't have to worry about that, okay? Just imagine a situation without a calculator. Or what if they say, hey, on this math test, you can't use a calculator. There's very good examples where I know that you can't use a calculator because I either forgot to bring one and I can't buy one, okay? Let's not worry too much about that. And 23, and then 0.7. Let's do 100. Move to 0.7. 30, so we can go into 2.7, I think 7 times, so that would be minus 21. And this is 27. After that, we go into that 9 times, we add a decimal point, so this will be just 7.9. Cool? Does that make sense? Does anyone have any questions on that? Yes? No? Okay. Okay, let's do the quiz now since it's almost end of class. Sorry, I didn't get to the TED talk, but here, let me send the quiz to everyone. And then it's just 5 questions, very short. After you guys are done, you guys can leave. Yep. Oh, and Erickson, just everyone the homework. Yeah, yep, sure. Yep, Eric always sends the homework out on email. So you guys will get the slides and the homework. Don't worry about that. Again, if anyone has any questions, you guys can stay after class. I'll try my best to answer them, okay? Yep, once you guys are, once you guys are done, you can leave. Yep. And if you guys miss anything on the quiz and you need me to explain it, you can always, yep, okay, bye. You can always talk to me later after class.
Bye.
See you tomorrow.
I finished one.
Cool, okay. Yeah, bye, Richard. Oh. Okay, does anyone have any questions? Edward, do you have any questions? Okay. Lori, any questions? Okay, well, Geraldine. How about you, Eric? Any questions?
Kyle, I have a question.
Yes, yes, sir.
What's 1 + 2? I've been stuck on this problem for a while.
Right. Okay. So think about like you have a pencil, and then I have another pencil. So if I have one pencil with another pencil, oh wait, you can't really see the pencil, but yeah, there you go. So how many
As a
pencils do I have?
crayon. As a crayon.
Okay, fine. I have one crayon with another crayon. How many crayons do I have?
I don't know. 1.
What's after one?
I don't know my numbers.
Okay, I'm ending the class.
Okay.
See you later.